All right, so the next section in the notes here is all about stability and balance. And this is actually, it's just another little application of this concept of torque and how it pertains to things rotating. So imagine we got four different pictures here, A, B, C, D, and all in each of the four pictures we have the center of mass is identified for the vehicle. Now, an object that has a center of mass also, of course, has the ability to rotate. So in picture A, we have a nice wide base of support with two tires. But on the other three pictures, we're taking a look at, well, what if one of the tires was off the ground? And that gets us into this concept of stability and balance. So in picture B, there is the center of mass. It's straight down. It's to the left of the pivot point, so therefore the car is going to go back down. In picture C, though, the center of mass is directly over the pivot point, and therefore that this is actually balanced. So this has stability because there's a torque for some of the mass going down this way, and there's a torque for some of the mass going down this way, and those two torques are balanced, and that causes this to be balanced. The net torque of the system equals 0. So there's no rotation. And that's the concept of balance, is when all the torques add up and equal 0. Finally, in the last one, the center of mass is directly down, and it is beyond the pivot point, and that's going to cause rotation in this direction, and that will cause the car to flip, essentially. So as long as the object's center of gravity remains over the base of support, or the pivot point right here, the torque due to gravity will rotate back to the original, or it'll stay perfectly balanced in the middle. It's a stable equilibrium position. If it goes beyond that, it's going to rotate the other way, and you're going to have a problem. But if you can maintain it right at that point, it can stay right at that point. So here's a quick little conceptual example. How far out can a cat walk on a plank? And we'll take a look at this in class, but the cat has its own center of mass, the plank has its own center of mass or center of gravity, and together they make a center of gravity of the system. And right here, that center of gravity is all over the base of support. But as the cat starts to walk out, that center of gravity will move to the right as well, and then eventually we're going to get this point where the center of gravity is over the pivot point, or over the edge point, and that is the last point that this is balanced. So once the center of gravity goes anything more this way, this is going to cause some rotation of motion. So right now this cat is good, but eventually it will go off the edge, and we'll take a look in class about the math behind that. For example, you can go on your tippy toes, but you automatically end up leaning forward. So when you can test that yourself, you can stand with your feet against the wall, your front of your feet against the wall, so the toes against the wall. And when you bob up, you won't be able to maintain it because you have to move all of your mass over your pivot point. So your feet actually provide a wide base of support. So when you go up to your tippy toes, your center of mass has to go over your tippy toes, when before your center of mass was just over your feet. So if you face the wall and your feet are touching the wall, you can't stand on your tippy toes because you can't get your center of mass over the pivot point. And that's the point of this right here. This is the impossible balance. So just kind of walking you through what I just talked about. Another example, I remember doing this in middle school all the time, where you try to get the soda can to balance on its edge. So if you were to look or be able to look into the soda can, here is the liquid fill level, and there's a center of mass of that, and it is right over the pivot point. So if you fill up a soda can with the right amount of liquid, or you drink the right amount of liquid out, you can get it to balance on the ridge of it because the center of mass is over the pivot point. And that's really it for stability and balance. It's a really quick section, just kind of, again, an application of torques. The next two topics we're going to get into are based on Hooke's law and one of the applications of Hooke's law, so it'll be a nice little review, and we'll do that in the next section.